So for what values of x is x squared plus 2x greater than or equal to 8? All right, we're going to do both algebraically and graphically here. I find algebraic easier, but there's a couple methods for graphical. So if you wanted to try a graphical approach, graphically, okay, there's two ways. One is to move everything to one side. So our y1 would become what? So if we move everything to one side, we get x squared plus 2x and then minus 8. So if I subtract that, we want when is x squared plus 2x minus 8 greater than or equal to 0? So in our calculator, we're going to put y1 equals x squared plus 2x minus 8. Okay, and we want when this equation is greater than or equal to 0, right? So what are we looking for? When the graph is above or below? Let's look at this. So grab your graphing calculators. Okay, y equals. So we want when our equation is greater than or equal to 0. Does that translate to above or below? X squared plus 2x minus 8. Graph it. Oh, your windows might be a little better than mine. Does yours look like that? Okay. So graphically, first of all, what are the important points on this? What are we going to have to find? The x-intercepts, the zeros, right? The zeros are when our graph changes from a positive to a negative. And when this graph, it says, when is our equation greater than or equal to 0, we're really asking, when is y greater than or equal to 0? If we're solving graphically. So that means it's when is it, so greater translates to above. When is it above the x-axis? So looking at our graph, I do a quick sketch. Is it recording? Yeah. What are my x-intercepts? Can you tell what they are on the graph? Or do we need to actually use the 0 feature? Looks like 2 and negative 4, okay? And would you agree, looking at the equation, would it factor to that? Yeah, so we're happy with that result. So negative 4 and 2, and the graph opens up. So it looks something like that. So when is the graph above the x-axis? What portion? Greater than 2 and less than negative 4, right? Our graph is above, where's the highlighter? Right, we're above the x-axis here and here. That's when we're above. And so the solution would be when x is less than negative 4, how about equal to? Yes, less than or equal to. Or when x is greater than or equal to 2. So that's one method, graphically. Your calculator can shade. So no, that's not what we want. No, just ignore that. Okay, so there's another option graphically. So you could do y1 equal to x squared plus 2x and y2 equal to 8. So left side, right side. So if we did that, we'd have two lines, right? Now, I don't like this method as much. X squared plus 2x has the x-intercepts of 0 and 2, negative 2. Okay, and so 1, and then we have the line of 8 at y equals 8, which is a horizontal line. Okay, something like that. So in this, I don't really like this method, but it works. We're basically asking when is the parabola, because if you look at the question, it says x squared plus 2x greater than or equal to 8. So where is the parabola above the line, right? When is the parabola, the quadratic, greater than the line, greater than 8? So same idea in your graphing calculators. This one is nice because you can use the intersection feature, x squared plus 2x. Get rid of the minus 8. Oops. Oops. Okay. So delete that, and then we have line equals 8. And so we want, when is the parabola greater than the line? So you'd want to find the intersection point. Second, trace 5. We need both of them. So you're not finding your zeros in this case. So there's negative 4. And then scroll over to the other one. Here's the 2. Okay, so notice you still get this intersection point at negative 4. And this intersection point is at 2. And so here you're asking, when is the graph, when is the parabola above 8, right? Above 8, above the line y equals 8. And so again, it's still when x is less than, so it's this portion here, less than negative 4, greater than 2. I don't like graphical. I think it's more of a pain than not. Okay, x is less than or equal to negative 4, or x is greater than or equal to 2. Okay, we're going to try and squeeze an algebraic in here. I hope you have room. No? Yeah? A little bit? Algebraically, we'll go really quick. Did I spell it right? Algebra. Yeah. I don't know why it looks weird. Okay, how do we solve this algebraically? First step, because it's a quadratic. See, if this is a linear inequality, like 2x greater than 8, then you just get the, ooh, you can't even see that. You just get the variable by itself, just like in regular algebra, right? Divide both sides by 2, x is greater than 4. But because it's a quadratic, in all solving of quadratics, we always get one side equal to 0 and factor, right? But you're used to that. You've been doing that for like months and months. Feels like you've been doing it for years, hey? So we want one side equal to 0. So move the 8 over. At least we're consistent. Okay. So we're looking for, when is this positive or negative? Because we're saying x squared plus 2x minus 8 has to be, how do we say that? Is that greater or less than? Greater than 0. So if it's greater than 0, we want to know where is it? Positive. Yay. Okay, so we factor. And it factors nicely because I didn't want to throw in the quadratic formula yet. Yes, yet. All right, x minus and x plus what? X minus 2, x plus 4. Life is good. Our critical values are CVs, I like to call them. X equals 2 and x equals -4. So now what do? We draw a number line. And we need the points -4 and 2. Honestly, you don't have to draw all the numbers in between, unless you really feel like it. Just put your important numbers down, I say. Okay, and we'll divvy it up. You could even, for funsies, like, because it's an equal to, you could use like a solid line, right? Because then it'll remind your brain, I'm going to have equal to, oops, that's supposed to be black, 2 and -4. I don't know. That's just me being nerdy. Dotted line works too. Okay, so we're going to test, and I'm going to use my factors. So we're going to pick a value less than -4. Any value will work. What number do you want to use? I know, I like to be really creative. I'm going to use -5. What's an easy number between -4 and 2? 0, and then it's nice to keep your numbers small, right? And then what do you think I would probably choose for maybe a 3? Yeah. Okay, so let's test those. So we use our factors, -5 minus 2, and then -5 plus 4. I feel like I should move that down. So we just need to figure out if it's a negative or a positive. -5 minus 2 is a negative, and -5 plus 4 is a negative. Two negatives make a positive, because it's a product. I feel like this is going slow. Sorry, guys. Okay, 0. 0 minus 2. Oops. Oh, I threw a negative in there. 0 minus 2, 0 plus 4 would come out as negative, because we have a negative and a positive, which makes a negative. I'm going to circle it. And 3 minus 2 and 3 plus 4, you would have 3 minus 2 is a positive, 3 plus 4 is also a positive, so positive. When do we want? Do we want where it's negative or positive? Positive. Good. So what's our solution? Surprise, surprise. When x is less than or equal to -4, we have the equal to because the question has the equal to, or when x is greater than or equal to 2, right? We want the positive portion. So we want here and here. Yay! Do you want to try one all by yourself? No? Okay, give it a shot. No? Do you want me to get you started? Oh my goodness, silly. Negative, oh, that's not a pen. Negative x squared minus 3x. Now you can leave the negative, or you can put everything on the other side. It's your call. I'm going to, remember, we bring everything to one side. It's okay with having that negative on the outside. It's no big deal. Just have to account for it when you're doing your tests. Now, you could also solve, like, is anyone moving everything to the other side? Yeah, so if you move everything to the other side, you have when is 0 greater than x squared plus 3x minus 10. You're going to get the same answer in the end. So I'll do both, whatever you choose. Doesn't matter which method you use, you'll get the same answer. So you can check your answer for both. Okay, that's a lot of writing. So, did anyone leave the negative and factor from here? Anyone? Yeah, a couple of you? Okay, so we left, factor out the negatives. We need to factor it out before we factor. You don't have to, but it's a lot easier to factor that way because then you won't have a negative x in there. And so I got negative times x plus 5, x minus 2. My critical values are x equals negative 5 and x equals 2. And so we want when it's greater than 0. So where is it positive? So when you do your test, you have to account for that negative on the outside. Okay? So notice here I have the negative. Here's that negative times my test value of negative 6 plus 5, my test value of negative 6 minus 2. So the negative times a negative times a negative gives me a negative. So again, you have to leave that negative on the outside. You do your test. 0 plus 5, 0 minus 2. So a negative times a positive times a negative gives me a positive. And then the negative on the outside. My test of 3 plus 5 is a positive. 3 minus 2 is a positive. A negative times a positive times a positive is a negative. And so in this case, if you solved it this way, we wanted where it was positive. Where is it positive? Between negative 5 and 2. Okay? Now, if you moved everything to the other side, if you decided, I don't like the negative x squared, which, hey, I'm with you on that, you just have to be very careful. So we're saying 0 is greater than x squared plus 3x minus 10, or we're really saying when is x squared plus 3x minus 10 less than 0? If we read our variables first, when is that less than 0? So it's nice to actually put the 0 for the inequality on the right-hand side, and the x is on your left, so you read it properly. And so I rewrote it so that it's x plus 5 times x minus 2. When is it less than 0? Where is it negative? So that's where you're solving. Your critical values are still negative 5 and 2, but your tests come out as opposite because you moved it to the other side of the equation. And we're looking for where is it negative. So when we do our test, I chose -6. You could do any number below -5. So -6 plus 5 is a negative. -6 minus 2 is a negative. Two negatives give a positive. Any number between -5 and 2, I chose 0 because 0 is easy. 0 plus 5 is a positive. 0 minus 2 is a negative. Positive and a negative gives a negative. And then any number above 2, I chose 3. I like to keep my number small. 3 plus 5 is a positive. 3 minus 2 is a positive. 2 positives is a positive. We want, where is it, negative? And so it's negative between -5 and 2. Okay? You can also check your work graphically. So on your graphing calculators, whichever one you chose, so once it was all on one side, oops. So if I use the first equation here, okay, y equals, so you could go to check your work, use your graphing calculator, -x squared minus 3x plus 10. We want when it's above the x-axis. And so it's above the x-axis between -5 and 2, right? If we graph this equation here, oopsie, it would be y equals opposite signs, right? X squared plus 3x, oops, plus, I know it's long, minus 10. Okay, and we want, where is it? Less than, so where is it? Below. And it's below between -5 and 2. So you can use your graphing calculator to also check your work. Okay? Whew! Turn the page. Oh! Oh, no! Stay there. Okay, because I put my stuff here. Okay, let's look at a different case. Silly minus sign. Okay. First step, algebraically, is to do what? Everything to one side. Let's bring it all to which side? Left or right? Yeah, I'm with you. Let's keep that beautiful x squared a positive. So we have x squared minus 4x and plus 5. Okay? So, does this factor? Can you factor that? So, only way to multiply to a positive 5 is 1 and 5 or -1 and -5. Can you factor that? No. Okay. So, guess what? If we cannot factor, like this case, we use quadratic formula. Okay, let's do that. X equals -b plus or minus the square root of b squared minus 4. Do we have to really write it out? Okay, AC all over 2a. Okay. I just get singing, and next thing you know, it's just okay. So -b would become what? -4 or a +4, right? Because it's the opposite sign of b. Plus or minus the square root of. So b squared, -4 squared is 16 minus 4 times, our a is 1 and our c is 5. Is that possible? No solution here. Okay. So really it's, or saying no, actually, and instead of no solution, we actually have no what? X-intercepts. Okay? So what that means is, this doesn't mean that there's no solution. I should just say no x-intercepts. Okay, no x-intercepts. Because there is no zeros. No zeros. So what that means is we have one of two cases. Okay, first case is it's above the x-axis. And second case is the graph is below the x-axis. Right? And where do we want? Do we want where our graph is positive or negative? Looking at our equation up here. when is it positive, right? X squared minus 4x plus 5 has to be greater than 0. So we want, where is it positive? We want where x is, or sorry, not x, where the graph is positive, where it's positive. So we either are going to have two cases. Either, in a situation like this, you're going to have no solution, or you're going to have everything. All of them. All the x's. All or nothing. Or XER. Okay, that's going to be your situation. So you have to figure out, and a lot of times you can use your A value to kind of figure this out. Is it opening up or down and there's no x-intercepts? So since in this case, is our A positive or negative? Our A is our leading coefficient. Coefficient in front of the x squared. On the boxed equation. A is positive. The graph is opening up. So we are the situation, no x-intercepts but opening up, and we want, when is our graph greater than 0 or above the x-axis? The answer is what? For all of them. So our answer is x is an element of the reals. Okay, can you check your work? Sure, pick any x value. Sure, 0, any x. So you can check, choose any x. Because we have XER. So we're going to use x equals 0. And what was the original equation? 4 times 0 minus 5 has to be less than x squared. Is that right? Is that right? Yes. Okay. What is 4 times 0 minus 5? Negative 5. Is that less than 0? Yep. Okay. So if that came out false, then you should have had no solution. You mix them up. Because if there's no x-intercepts, it's either going to be all or nothing. Whew. One more answer question with a beautiful, beautiful quadratic formula. Darn minus sign. Gosh darn it. For what values of x is x squared minus 1 less than 2x? So let's move everything to the left, to the left. Everything I want is in the quadratic to the left. Oh dear, I know. I need to get out more. Clearly. Yeah. Okay. Quadratic formula. X equals negative b. So the negative b becomes 2 plus or minus the square root of b squared. What is b squared? 4 minus 4 times the a is 1 times the c of negative 1. All over 2 times a, so 2. So what's the inside going to be? 8. Good. So your 4 plus 4, or 8. Where can we go from here? Can we simplify our radicals? Yeah. Root 4 times root 2. Or, some of you, actually, if I were you, like as an AP student, could we just go straight to writing 2 root 2? Yeah, I probably would. You could even write like 4 times 2 here, square root of 4 is 2, I don't know. Are we done? No. Can we simplify our coefficients? Yeah, remember you have to be able to simplify all 3. We can divide all 3 of these by 1. So what does it equal? 1 plus or minus 1 root 2, or just root 2. Do you have to write divided by 1? No, you don't have to write divided by 1. Okay, number line time. Now, as an AP student, Okay, if you were non-AP, I'd say let's just put this in our calculator and get the decimals and write the answers with decimals. But guess what? You're AP students. So we want to leave it as an exact. Yay, because you're special. Because in calculus, that's what you have to be able to do. Okay, we leave things as an exact. So our number line, when we make our number line, where should I make it? Over here, okay? We have 1 minus root 2 and 1 plus root 2. Now, do you know what root 2 even is? It's one of those numbers that you should kind of know. I think. No?
Is it like 1.14 or something?
You're on the right track.
But like it goes on like it's non-terminating.
It's non-terminating. Yeah, it's irrational. I'm trying to remember what's so special about root 2. It is irrational. There's something special about it. So 1.41. You were close. 1.41. Okay, 1.4-ish. So knowing it's 1.4 gives you an idea-ish on the number line. So 1 minus 1.4 is approximately what? Approximately negative 0.4. Yeah? And this, if you have 1 plus 1.4, it's approximately 2.4. Okay? So by knowing that number, root 2, it helps you with your number line. But we're going to leave everything as an exact. When we do our test, do we have factors to use? To test? No. So we have to actually use the x squared minus 2x minus 1 in our test. Okay? So give me a number less than 1 minus root 2. Okay? Nope. Close. Negative 2, sure. A number between the two of them. 0. And a number greater than 1 plus root 2. 3, sure. Okay? And so we have to use our original when we test because there are no factors. So we have to use x squared minus 2x minus 1. So negative 2 squared minus 2 times negative 2 minus 1. Is that going to come out positive or negative? Well, let's check. Negative 2 squared is positive 4. And then you have a minus 2 times a minus 2. So you have 4 plus 4 minus 1 comes out as positive or negative? Positive. Okay. 0 is easy, I think. Positive or negative? Negative. It'll be negative 1, right? And it's a quadratic. So here's the cool thing about quadratics. Quadratics follow a certain pattern, right? We know 2 x-intercepts. So the first is positive, then it goes below the x-axis. And not, right? It's going to be positive, negative, and you should be getting what for the next one? Positive, yeah. Like we're not dealing with a cubic here that goes down. So it's pretty obvious, but 3, we could check it. 3 squared minus 2 times 3 minus 1. We should be getting a positive. Is that positive? Yes. And where do we want? Do we want where it's negative or positive? Where is the equation? Positive or negative? Negative. Okay, less than 0, right? Less than 0. So our answer is where? Between our two values here, right? That's where it's negative. That's a pretty answer, no? Would we have an equal sign? No. 1 minus root 2, 1 plus root 2. I love it. It's beautiful. Okay. There technically is one more question. And because you're an AP class, we're going to do it. I know. It's optional, but because we're AP, we're going to do it. And then we're done. I know, it's so long. It's painful, but we're almost done, right? We're near the end. I'm pretty sure the other lessons aren't as bad. 9 point. Yeah, we went out of order. Yeah, on purpose. Okay, solve by graphing. So graph each side of the equation. See which equation is above or below the other. That's our option for solving this. So let's go over this. Let's do this. We kind of talked about this already, right? Is this a negative? Yeah. Okay. So let's do y1 as x squared and y2 as negative x plus 2. Let's graph this by hand. Do you guys, I'm hoping by now you can graph x squared by hand without a graphing calculator. So 0, where's our vertex? 0 and 0. Then what happens? 1 squared is 1. 2 squared, we're going to go up to 4. And 3 squared, 9. Negative 3. Okay. Next graph we're going to do is negative x plus 2. So where do we start with that? How do you graph negative x plus 2? Okay, y-intercept is 2. What's our slope? Negative 1. So what direction are we moving? Down 1, right 1. Hey, look at that, an intersection point. That might be important. You can cheat if you have a ruler. Is that cheating? I don't think it's cheating. It's cheating if you have technology. Ooh, that's a pretty light line. Okay, so where is our solution going to be? Someone to explain to me what we're looking for here. When is what above what? Or when is what greater than what? Okay, when is x squared, or the parabola, above what? Our line, negative x plus 2. The line. So where is the quadratic greater than the line? At what point? Okay, where is the intersection point? Sorry. Intersection, where is the intersection? The x value of the intersection. Negative 2, and the other intersection's at? So our critical values are at negative 2 and 1. So our quadratic is above when we are less than negative 2. Oops, that's not a highlighter. Okay, would you agree with that? And greater than 1? Right here, here it is, right there and there. Yes? We're okay with this? Okay. So our solution is when x is less than negative 2 or when x is greater than 1. There you go. Is there an equal to in the question? No, there wasn't. Okay. So not bad. I mean, I think algebraic's easier. But maybe that's because I'm biased. I have a prejudice. I like the math. I want to do it. Okay. So that is today's